Tuesday. We are moving forward for the rest of this week. I'm closing out chapter 10 in your algebra book, and I've kind of selected like the most important lessons. So yesterday we looked at simplifying radicals, and you'll see why you need that today. And then today we're going to be looking at solving radical equations. Now, when I went to go observe at the high school, this is a lesson that they were doing in their honors geometry class, like they were using it for like within like geometry concepts too. So it'll be important for next year. So stay strong. I know you guys are getting tired, but you are almost there. So here we are. Okay, your objective for the day is that you can solve radical equations. Essentially, any equations that have a radical sign, you're going to be able to solve them by the end of this lesson. Let's cover some foundations though. And this is something that we haven't really talked about too much, but once you see it once, it's really not too complicated. Okay, if I gave you an equation like this, and I said 2 rad x minus rad x, this is kind of like thinking of combining like terms. This is like the same thing as saying this. If I said 2x minus x, you guys would be like, okay, duh, that's just 1x. Same concept here. Your radicals that are the same, like rad x, or like rad 2, those act as like terms. Then you just need to subtract the coefficients. So if I have 2 rad x minus rad x, remember that there's like a pretend radical or like a pretend coefficient of 1 here. And then our final answer would just be 1 rad x. Or you're probably already saying like, can it just be rad x? Of course it can. Down here, notice that they both have the like term of rad 2 and rad 2, so that'll stay the same. And then you're just going to subtract the coefficients. 4 minus 2 is just 2. That's it. Okay, very simple. However, it won't always be that simple. Notice that you have 4 rad 50 minus 7 rad 18. Okay, first of all, I don't know about you, but when you see something like that, it's like, okay, yikes, that's kind of a lot to handle. You need to convert them so that they're the same number underneath your radical sign. So it's almost like they have the same like terms. To do that, you're going to use your simplifying strategy that we did yesterday. So let's start off with 4 rad 50. We're going to simplify rad 50. So if you ask yourself what are 2 factors that multiply to 50, one being a perfect square, again, go through like 50 and 1, 25 and 2, 5 and 10. I know right away 25 and 2 is going to work. So here's what I've got. I know that 25 times 2 gives me 50, and I can simplify square root of 25 to 5. What you need to be cognizant of, though, take a look. So we still have this 4 on the outside, and we have a 5 on the outside. Those will multiply to 20. And then notice you still have rad 2, and we're just going to keep that underneath our radical right here. Okay? And that's as much as you can simplify. Now, you know that you're going to be wanting this guy over here to also have a radical of 2, so keep that in mind with your strategy. Okay, so for simplifying 18, think of 2 numbers that multiply to 18. I'm thinking like 3 and 6, 18 and 1, or 9 and 2. Okay, 9 is your perfect square. So if I've got 9 and 2, I know that I'm not going to be able to do anything with this rad 2. It can't simplify that, so I'm going to highlight it. I'm also going to highlight this 7 because I know I'm going to need to incorporate that. And I know that the square root of 9 is 3. So we're going to multiply 7 times 3, which would give us 21. And then it keeps as the rad 2, okay, because we can't simplify that. Now, this problem you're ready to solve. You're good to go. 20 rad 2 minus 21 rad 2. You're just going to keep the rad 2. What's 20 minus 21? And it's just a negative 1 rad 2. Or your answer could just be looking like that. So just to sum up this little part here, if you've got the same like terms here underneath the radical, keep the radical and just subtract your coefficients or add whatever it's asking you to do. But if you don't have like terms, you just need to simplify so that they have the same number underneath your radical, and then again, you can perform the operation asked for. Okay, now we're really diving into lesson 10.4, which is solving equations with radicals. And a radical equation is essentially an equation that involves a radical, or when you have a variable underneath your radical sign within your radicand. Sorry. Here's something to keep in mind for all of today, and that is the use of inverse operations to solve equations. So if I gave you the operation division, what would be your inverse operation of that? What's the opposite of division? Okay, well, I know that that's multiplication. What's the opposite of addition? That'll be subtract. Yikes. Sorry. That would be subtraction. What is the opposite of a quantity squared? So that's like x squared. How would you undo that? Okay, well, I know to undo x squared, I'd have to take the square root. And then if you had like a radical like this, the opposite of this, which is what we're going to learn about today, is squaring it. So let me just sum up for you. If you had x squared and you wanted to get x by itself, you would do the opposite. You'd take the square root. Or if you were given the square root of x and you wanted x by itself, you do the opposite and you would square it. That's going to be your biggest tool for today to help you be successful. So here we go. This is example number 1. You've got underneath the square root sign x plus 3, and then you've got minus 2 equals 9. Your goal is not only to get rid of this radical sign, but always, just like we're solving equations, to isolate x here. So the first thing that we can do, let's get rid of this minus 2 and move it to the other side. And again, we do that if you've got minus 2, the opposite is the addition of 2. So I do plus 2, and that gives me 11 over here. And notice I still have the square root of x plus 3. Well, we were just talking and we said that if you have something underneath a radical, the only way that you can undo that is actually by squaring that quantity. So to get rid of that radical here and to start isolating x, we have to square both quantities. And here's what it looks like, especially if you're working this out. So you do squared and squared. Whatever you do to one side in an equation, you have to do to the other. So when you square this quantity, that would just give you x plus 3. Essentially, you just remove the radical. And then 11 squared is 121. And then your last step to solve for x is subtract 3. And you get that x is equal to 118. The biggest thing that I need you guys to see here is when we're solving for variables, especially when they're under radicals, not only do we need to get this radical quantity here by itself, but we also need to get our variable by itself. To undo or eliminate a radical, we're going to square both sides of the equation. Let's try another one. All right, so here's example 2. Now, if I asked you what variable you're solving for, hopefully you can tell me that it is x. That's the only one that's in there. But there are a few steps that you're going to have to do to get this x by itself. Do you see how you have this 2 outside the radical sign? We know that our goal is to get this square root of x over 4 by itself. Okay? To do that, if 2 is being multiplied, what's the inverse of multiplying? Well, I know that it's dividing. And then as soon as you divide away this coefficient here, it goes away. And then obviously you're left with just the square root of x over 4. And then I know that 3 divided by 2 is 1.5. So here's what I have right now, you guys. I've got 1.5 equals the square root of x over 4. In this guy back here, when we isolated this square root of x plus 3, we squared both sides. We're going to do the same thing right now. Okay, so here's what it looks like. Notice both sides we take the square of. We put it to the exponent of 2. So when I do the square root of x over 4 squared, this 2 and the radical sign, they cancel each other out, and you're left with just x over 4. And then in my calculator, I did 1.5 squared, and I got 2.25. Okay, notice that this exponent of 2 just eliminated the radical sign. Quantity stayed the same. Last step to get x by itself, if it's being divided by 4, we multiply both sides by 4, and you are left with 9 equals x. And that's your solution. Moving on. Okay, so here's example 3. This is when we have radical signs on both sides. Okay, notice that you've got it here and you've got it here. Well, I know that the only way to get rid of that radical sign is to do the inverse operation, which means that you're going to square both sides, just like we've done in the past examples. So it looks like this. Square both sides, square both sides. And then it actually turns out to be really easy, because when you do that, you're left with just 5t minus 11 equals t plus 5. Then it's just solving an equation. So if this was me, I'm like, okay, well, I see that I've got to combine like terms. I'm going to do minus t, and that's going to give me 4t. And then I add my 11 to the other side, so then 5 plus 11 is 16. If 4t equals 16, divide both sides by 4, t equals 4. Now, here is what we're going to start doing. We're going to start testing our solutions to make sure that they work. So if we know that t is equal to 4, let's put it back in that original equation I'm just going to write right over it. I hope you guys don't mind. And see if it works. So 5 times 4 is 20. 20 minus 11 is 9. Square root of 9 is 3. So we know that this side is equal to 3. 4 plus 5 is 9. Square root of 9 is 3. This side's equal to 3. If they're equal on both sides, you did it right. Congratulations. All right, here we are. So now why don't you guys pause the video and then you guys give it a try. Same strategy here. All right, so I know that if I've got the radicals on both sides, to start solving for my variable, I need to square both sides. When I do that, here's what it looks like. Big parentheses, square this side, and then essentially it just eliminates and we're left with 7x minus 4 equals 5x plus 10. I know that I'm going to move over my 5x first, so I'm going to do minus 5x. Sorry that it's taking me so long to type this. Ooh. Okay, yikes. Okay, you get the idea. Minus 5x, and then you're going to add this 4 to the other side, and here's what you're going to end up with. You'll have 2x is equal to 14. When you divide both sides by 2, you get that x is equal to 7. Now, let's go ahead and test the solution to make sure that it works. So I know that x is equal to 7, so I'm going to plug that in here, and I'm going to plug that in here. 7 times 7 is 49. 49 minus 4 is 45. Okay, so over here, I've got the square root of 45. 5 times 7 is 35. 35 plus 10, again, is 45. So on both sides, I've got the square root of 45. I did it correctly. I am good to go. All right, so now we're going to move a little bit deeper into algebra. When you've got variables on both sides, you have to square both sides to solve. However, when you create this almost new equation, there's a chance that you might get solutions that are extraneous or that they don't work. They don't make the equation true. And let me give you a quick example. Let's say that my original equation is x equals 3. If I squared both sides, I'd have x squared and 3 squared, which would be x squared equals 9. When you take the square root of that, square root of 9, I know that the square root of 9 is 3 and negative 3. However, if I plugged in this negative 3 back to my original equation, does negative 3 equal 3? No. That means that this negative 3 is an extraneous solution. Okay? It looks like it'd be a solution, but it doesn't make the equation true. It's extraneous. So the only real solution is x equals 3. Okay, let me show you an example of that. If I gave you this equation, n is equal to n plus 12, okay, first of all, I know that as soon as I need to get rid of that radical sign, I'm going to square both sides, okay? So here's what this looks like. And I tried to write this out in my markers, so I apologize if it looks a little bit messy. So I squared this guy here and I squared this guy here. Now I'm left with n squared equals n plus 12. When you see that variable, or sorry, that exponent of 2, your brain better be moving and saying, uh-oh, this is going to be solving a quadratic equation. I know I'm probably going to have to factor. But first, we need to set everything equal to 0. Okay, don't forget that. That was just the last chapter. That was last week. So we need to set everything equal to 0. So we'll subtract over the n, and we'll subtract over the 12. Okay, so here's what it looks like. Set it equal to 0. Now, I need two numbers that multiply to a negative 12, but add up to a negative 1. Okay? I know it's not going to be 6 and 2. It's not going to be 12 and 1. I know that it's going to be 4 and 3, but if they multiply to a negative 12 and add up to a negative 1, which of those guys is going to have the negative sign? It's going to be your 4. So if we're solving this quadratic equation, we're going to solve by factoring. Here's what it looks like. N minus 4, because it's a negative 4, n plus 3. Remember that we set both quantities equal to 0 for us to solve. And when you do that, you'll get that n is equal to 4 and n is equal to negative 3. We have to test these out. Okay, and here's what it looks like. If I test out my first one, if I plug in 4 for n, okay, back to my original equation, I get 4 plus 12, which is 16. 4 is equal to square root of 16. I know square root of 16 is 4, so this one works. That means that 4 is a solution. Okay, so this guy works. When you plug in a negative 3 for n, you get negative 3 is equal to negative 3 plus 12. Well, negative 3 plus 12 is 8. Does negative 3 equal 8? No. that means that this guy is extraneous. So if you were looking at your assignment, it's going to be like, all right, 4 is a solution, -3 is extraneous. All right, last one, and then we are done. Here we are. We've got square root of 3y plus 8 equals 2. I want to isolate my variable, especially with my radical sign. So the first thing we're going to do is subtract 8 from both sides. When I do that, 2 minus 8 gives me a -6. Okay. Now, to start getting my variable alone, okay, I need to get rid of this radical sign. So I'm going to square both sides. Looks like that. When you do that, it'll just be 3y, and then -6 times -6 is a positive 36. When you divide both sides by 3, you get that y is equal to 12. You have to put it back in to test it. Here's the original equation. I'm going to take out my y, and I'm going to plug in a 12. When you do that, you get the square root of 36, okay, which is 6. 6 plus 8 equals 2. Does 14 equal 2? No. That means that this 12 is extraneous. There are no real solutions for this equation. There's nothing. 12 is extraneous. So let me just quickly recap for you, okay? When you're given equations like this and you're asked to simplify, if they have the same number or same quantity underneath the radical sign, you can keep that quantity and just perform the operation with the coefficients on the outside, okay? However, if they are not the same, you're going to have to simplify it all down, and then you can perform the operation that you see. Our key to success when we're solving equations with radical signs is isolating the quantity underneath the radical and squaring it to get rid of it, to eliminate it. But you have to remember to square both sides. We also talked about the importance of testing our solutions, which means that we take our solution, we plug it back in to make sure that it's correct. If, when we do that, we get one that makes it not true, that means that that solution is extraneous. So there are some times when you can have no solutions, meaning they're all extraneous. You can have one real solution, one extraneous, or 2 real solutions. Okay, so it's important to check. All right, and I think that's it. Okay, your Tuesday assignment is the 10-4 Pearson lesson quiz. This is the last assignment that you will do on Pearson. Yay, I know you guys are excited. So my only recommendation to you is to work slowly. Take your time, work slowly, do the very best that you can do. All right, if you have any questions, let me know. So yeah, have a great day.